Now we are going to verify that your equation is correct by showing that f of f inverse of x is equal to x, and then you just do the opposite. You know, the f inverse of f of x is equal to x. So we're going to plug it in backwards. So the original one was f of x, but now instead of x, I'm going to plug in the inverse, which is, oh, I should put it back in function notation. I haven't been doing that, but technically the last step would be to put it back in function notation. So just replace the y with the f of x and rewrite it like this and like this. There we go. Okay, so we would write the function, the inverse function in here. So we would write f of x plus 12 over x minus 1. And we rewrite the original equation right here, but everywhere we see it, we write that. So we put, this is a bad one to do this experiment on. All right, so we would say f of 4x plus 12 over x minus 1 plus 12 over 4x plus 12 over x minus 1 minus 4. This is a terrible equation. Okay. So at this point, you'd have to get a common denominator. So you x minus 1 here, so you multiply the numerator by x minus 1. Over here, the same kind of thing. You multiply the denominator by x minus 1, numerator by x minus 1. Then you rewrite the whole thing of f 4x plus 12 over x minus 1 plus, and you'd have 12 times x, which is 12x, right there, and 12 times negative 1, which is negative 12. And you put that over x minus 1. And then over here, you would have the same kind of situation of 4x plus 12 over x minus 1, except now it is minus, there you go, and that would be 4 times x, which would give you a 4x. I'm just doing this distribution right there. And then 4 times negative 1, which is negative 4, all over x minus 1. And that would give me 4x plus 12 plus 12x minus 12 all over x minus 1 because they have like denominators. Okay, and then we'd say 4x plus 12 minus, parenthesis, 4x minus 4, in parenthesis, all over x minus 1. So we say 4x, see the plus and minus 12 there cancel out, leaving you just 4x I forgot to write my 12 there. Oops. Okay, got it. Okay, so the positive 12 here and the negative 12 cancel out. And then you say 4x plus 12x gives me 16x over x minus 1. I'll just do that, okay. And then over here, we are dealing with 4x minus 4x. So that just goes away. This and this will cancel out. And then we say 12 minus negative 4, which is the same as 16. Right? 12 minus negative 4 is the same as 12 plus 4, which is 16. We put that over x minus 1. These are going to cancel out. The x minus 1s are going to cancel out. There's a couple of ways to illustrate this. One is I can multiply both the numerator and the denominator by x minus 1. And then those will cancel out. It's one way to think about it. And that'll give me 16x over 16. 16s cancel out, leaving me x. So we proved it. You would do the same thing in reverse to prove that it is in fact inverse. Okay, use the graph of f to draw the graph of its inverse function. So what we would do here is we can basically draw a line right here. The y is equal to x line. Should be a line right here. And this would be reflected across this line. So let's try some of these points. So let's say this point here is 0, 2. 0, negative 2, and this point right here, we would say this one is positive 2, and we would say it's negative 1, 2, 3, 4 and a half. Negative 4.5. That means the inverse should have a negative 2, 0. And I'll use a different color to represent it. We'll do it at right about here. So it'll be negative 2, 0. And we should have a negative 4.5, negative 3, 4, 4.5, and positive 2 to be way over here somewhere. So we should have this right here, negative 4.5, 2 on it as well. Now, so my guess is the graph would look something like, oh shoot, I overshot it. Okay, well, it looks something like that. Hopefully your graph turns out better. But it should look something like that. It should be reflected across this y is equal to x. Y is equal to x right there. Given the function f of x is equal to x squared minus 6, where x is greater than or equal to 0, find the inverse function. All right, so we replace f of x with y. We keep the x squared minus 6. We switch x and y, so it ends up being x is equal to y squared minus 6. We isolate or get y squared by itself, so we undo the subtraction of 6 by adding 6, and whatever we do to one side, we do to the other. That gives me x plus 6 is equal to y squared. Next, we take the square root of both sides. Technically, this is the wrong notation because that's the principal, so that's only the positive ones, but try to write down kind of what we do. I'll erase that. That's really what you're doing. You're taking a square root of both sides. Anyways. Okay, so what that does is give you y is equal to plus or minus the square root of x plus 6. All right, so we're going to find the inverse, of the same rectangular coordinate system. So graph f and f inverse in the same rectangular coordinate system. Okay, so the first one would be, all right, so maybe I'll make this one blue. Make this one blue for the original one. So it'd be 1, 2, 3, 4, 5, 6. And then we select this and this. And then, so we have 1, 2. And then 1, 2. So it looks something like this. And something like this. Like that. Okay, so now we'll do the other one, which is plus or minus the square root of x plus 6. So plus 6 will make it go 6 over here somehow, right? Plus 6. So it'd be 1, 2, 3, 4, 5, 6. Yeah. And then what we end up with is something kind of like that. And kind of like that. And what should have happened, if I could draw our graph very well, is that this should be symmetric kind of with respect to y is equal to, so y is equal to x. It should be symmetric across there. It should be flipping across there. I didn't draw this to scale very well. This should have crossed over a little bit closer, but it'll be something like that. So the positive and the negative would be, you know, the one on top and the one on the bottom for the square root of x plus 6. Okay, so that wasn't a very good one. Okay, so use interval notation to give the domain and range of f and the square, and then inverse of f. Okay, so use interval notation to give the domain. Now the first domain is infinite. So the domain, so it would be like fx domain would be, whoops, we'll do this instead, negative infinity to infinity. And then we could do, whoops, domain is limited to, and we can even show the work here, right? Because that's a limitation because it's square root of x plus 6. So let's even write that. So x plus 6 greater than or equal to 0, minus 6, cancel, cancel. X is, whoops, greater than or equal to negative 6. Okay, so that means is you start at negative 6, and then you go to positive infinity.